think I was a little off on it. Anyway, all right, lesson 16, people. Symmetry. All right, symmetry. So if things are symmetrical, that means they're going to be the same distance from side to side, above or below that's there. We use words like reflections are things that are here. So let's see here. When two ordered pairs differ only by the sign of a coordinate, then the locations are reflected across an axis that's there. So yeah, if we've got different signs, same digits but different signs, those are opposites. So we are going to see our opposites come back into play here. So the idea here, if we take the number, let's see, give an example of two opposite numbers. Okay, 4 and -4 are definitely opposites. Where do these numbers lie on the number line? Well, someone is 4 to the right, and then our other number, our -4, is 4 to the left. So same distance from 0, but one is positive and one is negative. Yeah. All right. So let's see what else we got going on here. So we got into that discussion that's there. Here we go. Here we go. All right. All right. Here is what we want to get into. All right. All right. So we're graphing here. So we are in the U-turn section here. We are going to look at point S, all right, which does, I'm going to kind of shrink my screen here a little bit just so we can kind of see everything that's there. Hey, there we are. All right. So we're going to start with point S, so it's to the right 5, and then it's up 3. So the labeling, yeah, it's almost like the labeling's kind of off here a little bit. So ignore, and I don't know if yours are labeled correctly here, mine certainly aren't. 5, 3, so it's the right 5 up 3. So this is going to be my S that we're going to be using. All right, -2, 4. All right, that's going to be our letter. Let me make sure. No, they don't give you letters that are there. Well, that's disappointing. All right. Well, let's get into it here. We want to reflect across the x-axis. So the idea here is there's my x-axis. If we reflect it, it's going to have the same distance on the other side. So if we count, it's 1, 2, 3 to get to the axis. So I continue to count. A 1, a 2, a 3. So there's our point. So if we look at this, where is it at? It's to the right 5, and then it's down to -3. Take a look at your ordered pair that's there. You have a bad looking 3 there. That's the case. All right. What we have here are some similarities. I tried. Look, the 5 stayed the same, but the 3 went from a +3 to a -3. So that's a little bit better. That's an idea of a reflection that's there. It's very visual. Normally we don't focus in on the ordered pairs, although we will notice them. But really what we're acting is their visual that's there. All right, so let's go back to this point S here again, and let's reflect it across the y-axis. So that y-axis goes straight up and down. If we count, we are 1, 2, 3, 4, 5 away. So we're going to go the other side. 1, 2, 3, 4, 5 away. So where are we at? Well, to get to that point, I have to go to the left to -5, and I've got to go up to a 3. And again, if we notice based off the originals, 5 and -5 are opposites, and the 3's ended up staying the same. So let's try a few more of these guys here. Let's come on over here and let's try this guy, this ordered pair -1, -5. So we're going to go to the left to -1. We're going to go down to -5. If we reflect across the x-axis, how far are you away from the x-axis there? Well, yeah, you're only 1 away. So I'm going to be right on the other side of it there. So if we ask for that ordered pair, we had to go to the right 1 and then down to -5. So 1, comma, -5. And then the idea here, there we go, is if we look at them, the first numbers were opposites, the second numbers remain the same. Let's do the same thing, but we'll reflect it over the y-axis. Oops. Did you see the mistake that's there? Yeah. That wasn't over the, yeah, wait a second. I did it right here. All right, let me get that eraser out. Whoa. Glad I caught that there. All right, so let's go back here again. All right. Yeah, reflected over the y. Yeah, there's my y-axis that's there. So this one wanted reflected over the x-axis. There's my x-axis. So how far am I away? Well, I'm 5 away. So I got to go up 1, 2, 3, 4, 5. There we are. So if we look at that ordered pair, it's the ordered pair -1, comma, and then 5. So that's what we're looking for. All right. It's counting. It's visual. But again, we certainly will notice some patterns that go along with it. So for example, what we want to notice is that when we do reflect over the y-axis, it's the x-coordinate that becomes the opposite, and it's the y-coordinate that stays the same. Again, I don't think we need in-depth analysis like that, but it is certainly a pattern that we're going to be watching for. And this is what's going on here. So when the x's change, but the y's stay the same, all right, and we kind of come back up here, all right, here, all right, if we had a -1 and we reflected over the x-axis, the x-coordinate stayed the same. If we reflected you over the y-axis, the y stayed the same. So, since the y stayed the same, yeah, that would be a reflection over the y-axis. Again, I don't think that's really where we're going at it. The main thing is a reflection. It's the same distance away from your axis, but you just got to go over it on the other side. Yeah, I agree. It's been enough here, people. We'll get into this more tomorrow. I'll see you guys.